everyone joining today, and thanks for tuning in. I'm Isabella, a PhD student with the Exercise Physiology and Cardiovascular Health Lab at the University of Ottawa Heart Institute. I'll be your host for today's special episode of BEaTS Research Radio, a YouTube channel and podcast which aims to disseminate science to the community. Our guest today is Dr. Gabe Gomes. Gabe Gomes was born and raised in the countryside of the state of Rio de Janeiro, Brazil. He received his bachelor's in chemistry with technological attributes from the Federal University of Rio de Janeiro. He earned his PhD at Florida State University, investigating the relationship between molecular structure and reactivity. In the next year, he joined the University of Toronto, Canada, as a postdoctoral research fellow, where he was awarded the prestigious Benting postdoctoral fellowship with the project Designing Catalysts with Artificial Intelligence. Now, with his own lab at the Carnegie Mellon University, located in Pittsburgh, USA, he and his group seek to solve questions by combining state-of-the-art machine learning, computational chemistry, and automation. Welcome, Dr. Gabe, and thank you for being here.
Yeah, thanks, Isabella, for hosting me. It's a real pleasure to be speaking with you here today and speaking with BEaTS.
So for an easy start, can you talk more about the importance of developing new catalysts, their reactions, and how your lab aims to flip this process on its head?
Yeah, pleasure to do so. So it's interesting. We have been all talking about so many ways where computers have changed our lives and how machine learning is so intrinsic with modern living. But we kind of don't talk about one of the coolest technologies that humanity have developed, which is the ability to manipulate atoms and break and form bonds. And if you want to break and form bonds to make new drugs, new materials, new energy and fuel, you probably are going to use a catalyst, which is an active, let's put it this way, ingredient in the reaction that you're trying to perform that either makes that reaction go faster or even make impossible reactions actually happen. So that's why I'm interested in developing catalysts, because while they are so important, and nature has also figured this out by developing what are nature's catalyst enzymes, right? This hyper evolved and hyper focused proteins that can catalyze very specific reactions. As a society, we still need to develop our own catalysts, and that takes a lot of time and a lot of financial resources. In fact, to develop a new material, it costs on average about $10 million in 10 years. How can we make this go much faster, catalyze that process, if you will? So I think that the way to go about that is by using state-of-the-art computational methods and automation, and that's where my lab is focused on working.
That's awesome. Thank you. So your lab published this year a new approach to investigate and representing molecular structures with graphs. So could you tell us more about the impact of these findings?
Yeah, so as I was saying earlier, machine learning really has become a massive part of our, really of culture at this point. And a lot of it is developed by companies that have interest in understanding or, images, which are relatively cheap, text. Well, so it's relatively cheap to, you have a lot of data to train these massive models. And you have things now like DALL-E and the fusion models that can make amazing images from a prompt. You have things like AlphaFold from DeepMind that can, from a sequence of amino acids, can fold a protein. But when it comes to chemistry, you can't simply apply these methods out of the box because molecules are not images, molecules are not strings and text. Molecules are quantum mechanical, three-dimensional objects. They're always moving, they have their own energy, and like that is an intrinsic part of what these objects are. So for the past few years, a decade, like graph neural networks has become a very powerful tool in the tool set of machine learning. You can imagine social networks, for example, are represented as graphs, and molecules can be represented as graphs as well. But again, molecules are not graphs. They are these quantum mechanical objects. So this first paper, we showed that we can embed molecular graphs with quantum mechanical properties and features that dramatically reduce the amount of data that you need to train a model, and then can be used for downstream tasks. Really, the idea here is to enable other machine learning applications that now you can get the data much more cheaply. One of the main differences between using machine learning in physical sciences versus for images and text is that doing science is hard and expensive and time consuming. So how can we accelerate that? That's where we try to target here.
Wow, thank you. So speaking of which, when you're asked, can machines dream of molecules that cure cancer? You answer, you of course would like to say yes, but the reality is that we are still learning. So what have you learned so far, and what can we expect for the future in this field?
So I really like basing whatever we're doing on the realities that we are facing and on our limitations at the time. And that was that question, like, can machines dream of molecules that cure cancer, is a almost unfair question because there's not one type of cancer, right? And even if you target one specific type of cancer, they will manifest themselves differently with different patients. So going back to the question, can machines dream of molecules that can cure cancer or cure disease? Yeah, I like to say yes, and I think that we could get there, but we're not there yet, right? And that we are still learning. And say we, I mean us as like humans and scientists trying to figure out these problems, trying to figure out what machines learn, and trying to figure out how scientific understanding comes from these new methods that we have now. We really are at a new paradigm of how we do science and engineering. So I do expect that we're gonna get there, and we're gonna get to so much more. But it's going to be one of those things that we're only going to be able to tell in retrospect and not going forward. But that's exciting because, like, then all people should come and like, okay, let's solve this. Let's do these amazing things. Let's try to discover the next material that will help us clean water, that will help us develop new batteries, that will help us develop new drugs at a time that we need it cheaply, efficiently, so that we can deploy these not only in rich markets, but also in emerging markets that may not have all of the financial resources to purchase these things right away, right? So it's about democratizing science and data as well.
Well, that's great. I really hope you get there. So our last question, I heard one of your passions, music, and in alternative reality, you could even own your own studio to help artists to find their sound. So thinking about science, with your amazing background all around the globe, what advice you give to young scientists to find their path in academia?
So yeah, this is a I do love music, and it's a as you can see by like the albums on my wall here. So this is my very favorite album, In Rainbows by Radiohead, and then you have this one by Nine Inch Nails. This is Whiplash, the movie. So yeah, music is an important part of who I am, and I think that embracing it and really thinking how those things actually even change my view as a scientist are or influence my view as a scientist are pretty important. And I think that for young scientists, trying to find their path, um, really be passionate about what you want to do. So don't settle for something just because it's what's in front of you, but rather chase what you want to solve, right? Like find that and chase that and try to learn as much as you can about it, because that's the way to push the boundaries. um and finding your own path, it's hard. I think I'm still doing it. I don't think I have actually figured that out yet. um but I think that finding something, and what I'm not saying here is follow your passion. What I'm saying is to find something that you think you can have um, to really make a difference. And I want to also make another point, which is don't be afraid of dreaming big. Like really, I had this professor back in Brazil who would say, "Don't be careful of what you dream of, because you may achieve it." And that was always like, "Wow, okay, that's you." I always felt a bit like um, strange about that, but yeah, actually, that's actually true. And don't be afraid of it. Like dream big, go for it. That's how you achieve big things.
Well, thank you. So this concludes our interview today. I would like to thank you, Dr. Gomes, for the great talk combining machine learning and chemistry and music. So thank you for our listening, for checking out this BEaTS Research Radio episode. Subscribe to our YouTube channel or find us in your favorite podcast app. So, on behalf of the whole team here at BEaTS Research Radio, stay safe and heart health.